Good afternoon, this is Schweitzer, and this is a little preliminary video on we call our solubility labs, salts labs. So we have essentially objective predict the solubility of different salts, determine percent error. So we're going to spend some time predicting all of the solubilities of these chemical reactions. Then we're going to do a percent error based on what we had happen versus what we thought would happen. Okay, so first things first, it says materials. We need a pipette, microwells, and chemicals. So I'm just going to give you a little bit of a heads up on this. So we have, first things, we have a pipette. Well, pipette is designed as being basically like an eyedropper, and we may use these, or we might just literally use bottles, dropper bottles, and there they are looking like this. Okay, the names would be labeled clearly on the side. Then, because this is a micro lab, we would use what's called a micro well plate, and it's probably about the size of your palm. The ones we have relatively round dips in them, and there are a bunch of them. There are maybe 15 of these spread throughout this particular plate, and we will simply be using the dropper bottle to drop in chemicals and watch them react. You then take this particular thing and you to clean it, tip it outside into our waste container, and all the dips here, of course, here, and we usually use a squirt bottle, like a little handheld squirt bottle that we would use to squirt water and rinse everything in. Probably the biggest source of error in this lab would be contamination. So all this stuff drops in here. Now, at that point, we have soaking tubs that these things just sit in, and there may be one, or maybe I'll have two of them. One might be labeled soap, one might be labeled just water, or just depends on what I have set up. But it's important when you get these to make sure you get them clean. So if you pull one out of here, just make sure you take some paper toweling, and I just wipe out the little divots here with paper towel. Make sure there's no residual solids or anything in there. Alright, so let's go back to this particular lab, and it shows that we are going to be looking at these chemicals. Now, our little well plate that we talked about essentially is this grid. You need to create your own grid on the next page here. So under the data section, create your own grid as far as what you think is going to happen here. And at this point, we're looking at, let's say we have all of these guys here, and this little guy here, and I'll start by predicting all the reactions, and then we'll do the lab afterwards. So it says place reactions here. You might not have enough room, so you might want to do them somewhere else. It's easiest if you do a bunch of them first. I'm going to do them right here so I can see them. But I'm going to do the first column here, and it's going to be AgNO3 plus Na3PO4, and the predicted products of this guy would be Ag3PO4. This is plus, let me get rid of this guy, plus 1 minus 3, and then NaNO3 is the next option. Then we have FeNO3 plus Na3PO4, producing again NaNO3 plus Fe plus 3PO4 minus 3. Copper nitrate plus Na3PO4, copper phosphate This is a minus 3 plus 2, so a 3 goes there, 2 goes here, plus, and then again the NaNO3. Now the last one is going to be PbNO3 2 plus Na3PO4. And then this gives me PbPO4 parentheses 2, 3 plus NaNO3. So what we would do on our thing here is we would be taking our thing, and I would be using, okay, 4 of my wells, and I would be dumping sodium sulfate. Is that what it was? It was sodium sulfate to all of them, and then I'll be alternating with these guys. So Na3PO4 would get dumped into all of them, and this is a qualitative lab. So we're not looking for quantitative, just will happen or won't it happen. So let's just say be consistent. If you're adding 5 drops, then that's what you want to do. Then you consistently add 5 drops of all the other chemical, and then just simply watch, you know, and see what's going on. Okay, that's my eyeball. Alright, look for a solid. If there is a solid, then we would be okay, then that we should expect it to happen in real life. How do I predict this? Well, go to your solubility chart. I don't have that pulled up with me right now to pull it forwards, but you should do your quick check, which I would say these are all going to be aqueous straight down the line. And every NO3 the whole time will be aqueous, but these guys would not. Now on my chart it says that phosphates generally are insoluble unless the cation is sodium, potassium, or ammonium. So all of these guys would be solid. And now I have 1/4 of them done. You would want to do the rest of them, and you want to do them either on a separate sheet of paper, or if you can squeeze them into this area right here. On your data sheet, okay, so our first part of our data sheet is starting to take place. Na3PO4. Then I have my other solutions are AgNO3, AgNO3, FeNO3, 2, and then we got the other one is copper nitrate and lead nitrate, CuNO3, 2, and PbNO3, 2. So far, based on my predictions, I have a solid being produced in every one of these. So somehow we indicate that our prediction is that yes, we will have a precipitate. Now first, for me, sometimes I use this smiley face showing that yes, I'll have a precipitate. Then in lab, you would fill in your data, or it could be a color, or maybe you want to use a smiley face or a check or whatever, because we're looking to compare what we predicted versus what actually happened. And maybe there's some error, who knows. And this is again the solubility lab. Now percent air is located right here. So that means of the 16 total, how many did you predict would precipitate? So let's just say hypothetically that there are 16 and we predict that 12 of them will precipitate and 14 will not precipitate. So we would have 12 smiley faces and 4, let's say, not precipitating. So in this case we predict 12. So my prediction would be 12. My actual, so 12, and let's say only 10 of them did. Just hypothetically, go to your own data to figure that out, your own lab. And so 12 minus 10, and then divided by the actual saying is 10, and times 100. And this will give you your percent error. Another name for percent error is percent change. I've been aiming for that. Alright, so this is our lab, showing the pre-lab and giving you an idea of sort of how this lab works. Thank you very much.